Okay, today we're looking at DeepResearchEval, an automated framework for deep research task construction and agentic evaluation. This one comes from Yibo Wang, Lei Wang, and the team over at Infinity Lab and Nanyang Technological University.
And if you're someone who builds agents for coding, for market analysis, anything like that, this paper is, well, it's pretty essential. It tackles a problem that's just critical right now.
Which is what, exactly?
That are benchmarks for these deep research agents, the ones that write long, complex reports, are basically broken. They depend on humans, which doesn't scale. They use these static rubrics that don't really fit. And worst of all, they just ignore uncited claims.
So they came up with a fix, a fully automated framework. And it starts with something called persona-driven task construction. It generates realistic queries based on user profiles and then filters them to make sure they actually need a web search to be solved.
And the grading part is where it gets really innovative. They call it agentic evaluation. It has two pieces. An adaptive point-wise quality evaluation, that's a mouthful, which creates custom grading rules for each task.
And the second piece?
Active fact-checking. This is where a separate agent goes out and independently verifies the facts in the report. Doesn't matter if they were cited or not. It checks them anyway.
And the results from this new framework. They put 9 major systems to the test. For overall quality, Gemini 2.5 Pro came out on top, scored an 8.51 out of 10.
But, and this is the big but for factual correctness, the agentic generalist, Manus, actually won. It hit 82.3% accuracy, which was higher than Gemini and OpenAI. It shows that these agentic systems are just way more resistant to hallucination.
So it really draws a line in the sand. There are models that write well, and then there are models that research well. Okay, that's the 1-minute summary. Welcome to AI Paper Podcasts.
Let's slow down here and really dig into this, because for all of the engineers and researchers listening, this paper points out a huge gap in how we're all evaluating our models.
It absolutely does. I mean, we're seeing this explosion of what they call deep research tools. You've got OpenAI's version, Gemini's, Perplexity, and then these specialized agents like Manus.
Right. But we don't really have a good ruler to measure them with.
Right now. We can't really tell if they're doing a good job.
We know they can produce text. I can ask for a report on, I don't know, the future of AI compute investments, and I'll get back 10 pages of perfectly structured prose.
But how do you know if page 4 is just completely made up?
Yeah.
Exactly. And the paper argues that our current benchmarks, things like GAIA or these big question-answering data sets, they're just not cutting it. They're measuring the wrong things because they're static.
What do you mean by static in this case? Okay, imagine you're a professor, right? You have one student turning in a creative writing piece and another turning in a thesis on financial analysis. You can't possibly use the same grading sheet for both.
Right. You'd want to reward creativity in one, and you'd probably want to avoid it in the other.
But a lot of benchmarks apply these fixed dimensions across everything. They check for things like, clarity or instruction following. They miss the nuances. But the even bigger issue, and this is the one that really gets me, is what the paper calls the citation blind spot.
They were very clear on this. Most systems today only check a fact if the model actually attaches a citation to it.
It's a massive, massive loophole. If a model says company revenue went up 20% and puts a little 1 next to it, the benchmark checks that source. But if the model just says company revenue went up 20% with no citation,
it just hits a pass.
It often just gets ignored.
Yeah.
The system assumes it's fine because there's no broken link to check.
So the model learns that the best way to lie is to just do it confidently, without citing your sources.
Precisely. It encourages confident hallucinations. And then, trying to solve this by throwing people at the problem, it's just impossible. You can't hire enough experts to grade thousands of reports on niche topics like semiconductor supply chains.
Yeah.
It's just too expensive.
Okay, so the team decided to automate the whole thing, the questions and the grading. Let's start with the input side, the task construction pipeline. They didn't just scrape some forums for questions.
Oh, not at all. It's a very engineered approach. They started with 10 representative domains, things like finance, health, software development, and so on. From there, they used an LLM to generate 50 specific personas.
I think the paper mentioned one, Ethan Kim, an industrial IoT engineer. I actually love that they gave them names. It really grounds the whole process in what a real user would want.
It's so important for the prompt. So instead of a generic question like, tell me about IoT, the system now generates a task that Ethan Kim would actually need. Something like, analyze the supply chain risks for sensor manufacturers in Southeast Asia for 2026.
That's a real research task. It needs web browsing, putting different sources together, some actual analysis. But the part of this pipeline that I thought was genius was the search necessity filter.
Ah, yes. This is the quality control step. It's what ensures they're actually testing research skills, not just the model's memory.
So how does it work?
Before a task gets approved for the benchmark, they give it to a powerful LLM and tell it, answer this. But you can only use your internal knowledge. No Google, no tools.
And if the model spits out a great answer anyway?
The task gets thrown out. It's rejected.
Wow, that's pretty ruthless.
It has to be.
Yep.
I mean, if a model can answer the question just because it read some article about it during training, then the agent isn't really doing any work. The whole point is to test the agentic part, the ability to find new information and synthesize it. This filter guarantees every single task is an actual knowledge gap.
But did they check if this automated process actually works? You know, I'm always a little skeptical of synthetic data.
They did. They did a sanity check. They took a batch of these machine-generated tasks and gave them to 7 human PhD experts to review. 80% of the tasks were approved by at least 4 out of the 7 experts. For a fully automated system, that's an incredibly high success rate. Kind of proves that LLMs can design good tests for other LLMs.
Okay, so now we have a good set of hard, verified questions. Next, you have to grade the answers. And this is where they introduce the adaptive point-wise quality evaluation.
Right, this is the fix for that static rubric problem we talked about earlier. The system doesn't have just one grading sheet. It has like a dynamic engine for creating them.
Can you walk me through how that actually works?
Sure. So first, it applies 4 general dimensions to every single report. Things like coverage, insight, instruction following, and clarity. Those are your
It's
basics.
the standard stuff. Is it readable? Did it do what I asked?
Exactly. But then, and this is the clever part, it analyzes the original task prompt. So let's go back to our guy, Ethan Kim, and his supply chain question. The evaluator might generate new task-specific dimensions. It might invent a metric called, say, risk quantification or geopolitical sensitivity.
Whereas if the user was a developer asking for a code snippet,
It would generate metrics like code efficiency, error handling, or maybe dependency management. It literally builds a custom rubric for every single test.
and the paper mentions it weights these dimensions, right? Using a variable, WD.
Yes, it's a weighted average. The system gives a weight to each dimension based on what the user seemed to care about. So if you explicitly asked for a table comparing costs, the formatting dimension gets a huge weight. If you ask for creative new strategies, then insight is what matters most. It makes the score actually reflect the user's intent.
And this is a huge pivot in the paper. You can have a report that's perfectly formatted, follows every instruction, has great insights,
That is totally wrong.
and is completely factually wrong.
That's what they call the fluency trap. And it's exactly why DeepResearchEval splits quality from factuality. They're 2 separate scores. And to measure factuality, they built this active fact-checking module.
Okay, I want to focus on that word active. How is this different from just, checking the citations?
It's adversarial. The evaluator flat out does not trust the report. It parses the whole text and pulls out what it calls atomic claims. These are just verifiable statements, a number, a date, an event, who did what.
And it pulls these out even if there's no citation.
Especially if there's no citation. That's the whole point. It just creates a long list of all the factual assertions made in the report. Then it sends in a separate fact-checking agent. And this agent takes each claim and does its own independent web search.
So it's basically redoing all the research from scratch.
It is. It's not asking, does the source support the claim? It's asking, is the claim true according to the web? It finds its own evidence and then labels every single claim as right, wrong, or unknown.
This feels like the piece that's been missing in AI evaluation for a while now. We've been so obsessed with does it sound good that we forgot to ask, is it telling the truth?
And when you pull those 2 things apart, the leaderboards get really, really interesting. So they ran this whole thing on 9 different systems. You had the big names, Gemini, OpenAI, Perplexity, and you also had Manus, which they describe as an agentic generalist.
Let's get to the results. For report quality, so the structure, the writing, the flow, who took the top spot?
Gemini 2.5 Pro. It was the clear winner there with a score of 8.51 out of 10. The analysis showed it's just a fantastic writer. It organizes information well. The coverage is great. It just sounds very professional.
But then the truth police came in, the active fact checker, and the rankings changed.
They flipped.
Yeah.
For factual correctness, Manus was the winner. It achieved an accuracy of 82.3% on all the claims it made.
And where did Gemini, the quality winner, land on that?
Gemini 2.5 Pro dropped down to 76.62%, and OpenAI's Deep Research was just behind that at 76.21%.
That's a nearly 6% gap between Manus and Gemini. I mean, for research and engineering, a 6% error rate isn't a small thing. That's the difference between a tool you can trust and a tool that's a liability.
It is significant.
Okay.
And it really points to a difference in architecture, I think. Manus is built from the ground up as an agent. It iterates, it uses tools, it probably has more verification steps baked in. Gemini and OpenAI, while they have search capabilities, are still, at their core, optimized for fluent generation.
So Gemini might smooth things over, maybe invent a small detail just to make a paragraph flow better, while Manus might be less polished, but it's double-checking the data.
That seems to be the trade-off. Looking good versus being right. And for the kind of technical users this is aimed at, being right is almost always more important.
There was one other result that I found really telling. The gap they found between the general scores and the task-specific scores.
Right, this was across the board. Almost all the models did really well on the general stuff, like clarity and instruction following. They're all very polite, very professional. But when you look at those dynamic, task-specific metrics, things like scenario analysis for a business prompt or technical feasibility for an engineering one, the scores just tanked.
So what does that tell you about where these agents are today?
It tells me they're like excellent junior consultants who don't have deep domain expertise. They have completely mastered the form of a research report. They know what a good analysis looks like, but they still struggle to do the specific deep reasoning required to actually perform the analysis correctly.
So they pass the English test, but they might fail the engineering test.
That's a great way to put it. And it means if you just look at a high-quality score, you could be fooling yourself. You might think your agent is doing a great job because the output is beautiful, but it's failing on the very specific thing that your user, that Ethan Kim, actually needed to know.
So, okay, for the listener, if I'm on an ML team and we're building agents for our company, what's the big takeaway from this paper?
You have to stop using static test sets. If you're grading your agent on a fixed list of questions and answers, you are not getting the full picture. You need to adopt this active fact-checking philosophy.
Does that mean everyone needs to go build their own DeepResearchEval from scratch?
Maybe not the whole persona generation part, but you absolutely need the verification loop. If your agent produces a report, you should have another process, maybe a smaller model, maybe even just a script, that pulls out the key claims and tries to verify them independently. You just cannot trust the generative output on its own.
It's like having a red team model. One model builds the argument, the other tries to tear it down.
Exactly. And this paper proves that our models are finally good enough to be that red team. We can automate the grading process, but only if we separate style from substance.
I want to circle back one last time to that search necessity filter. They used it to weed out easy questions, but it also reveals something pretty interesting about the models, doesn't it?
It's a very provocative idea. By filtering out all the tasks that a model can answer from memory, they're implicitly showing us that a massive amount of what we think of as research is already just latent knowledge stored inside these models.
We use them like they're search engines, but maybe they're more like living encyclopedias.
Which raises the question, right? Are we underestimating how much these models already know, or are we just asking them lazy questions? And maybe more importantly, the fact that Manus, an agentic system, beat these giant foundation models on raw accuracy. It really suggests the future isn't just about making bigger and bigger models.
It's about building better workflows.
It's about better architectures. A specialized agent that knows how to think, how to check its work, and how to verify information that might beat a generic, super intelligent model on accuracy every single time.
That's the real shift then, from just generative AI to agentic AI, and now finally to verifiable AI.
That's where the whole industry needs to go.
We'll leave it there. This has been our look into DeepResearchEval. For the full technical details, we'll have the link to the paper in the description. Thanks for listening to AI Paper Podcasts.
Thanks, everyone.